Hey guys, Professor Calculus is here, and today in this video I'm here with you at solving this integral. Before we go, make sure to like and subscribe as it is free and you can always change your mind later. So, there is an easy way to solve this integral with a differentiation under integral sign, aka Feynman's trick of integration. So, we already have a parameter here, a constant parameter, and I'm gonna define this function as I of phi to be equal to the integral from 0 to 1 of x to the phi minus 1 squared over ln squared x dx. Now, if I take the derivative of this function, it's going to be I prime of phi, which is going to be the d phi of my integral from 0 to 1 of x to the phi minus 1 squared over ln squared x dx. And I can move this derivative, total derivative here, and it's going to become partial derivative. I'm going to write it in yellow. Partial phi x to the phi minus 1 squared over ln squared x dx. So what is a partial derivative? What is it? It means that we should consider all the terms that do not have phi in themselves a constant. This is a constant, this is a constant, and only the term that has phi in itself is a variable that we differentiate with respect to. Thus, I prime of phi is going to be 2 times x to the phi minus 1 according to the chain rule, multiplied by the chain inside this function, which is going to be x to the phi ln x over ln squared x dx. This is just straight up application of a chain rule. And I can cancel out these two ln x's, and my I prime of phi is going to be the integral from 0 to 1 of 2 x to the phi times x to the phi minus 1 over ln x dx. So I'm going to expand this a little bit now. I'm going to say my I prime of phi equals to 0 to 1. This multiplied by this is going to yield 2x to the 2 phi minus 2x to the phi over ln x dx. And if I take the derivative with respect to phi again, I'm going to have the partial phi of 2x to phi minus 2x to the phi over ln x dx. And my I prime of phi is going to be, if I take the derivative again, it's going to be 4 x to the 2 phi ln x minus 2x to the phi ln x all over natural log of x. And I can cancel out the natural log of x here, natural log of x here, and natural log of x here. And our integral becomes very solvable. I prime of phi is the integral from 0 to 1, 4x to the 2 phi minus 2x to the phi dx. Right now here the phi is a constant, therefore I'm going to first split up this integral and then I'm going to use the power rule to say 2 phi plus 1, 2 phi plus 1, the limit from 0 to 1 minus 2x phi plus 1 over phi plus 1, the limit from 0 to 1. If I calculate these limits, I'm going to be having, I'm going to calculate the limit here for x to the 2 phi plus 1 over 2 phi plus 1, the limit from 0 to 1. So then I gotta plug in first x equals to 1 and subtract from x equals to 0. This is going to be 4 quantity times 1 to the 2 phi plus 1 over 2 phi plus 1 minus 0 to 2 phi plus 1 over 2 phi plus 1. So the 0 to any power is 0, thus here I'm gonna cancel out this one, and the 1 to the any power is 1, so I'm gonna cancel out this as well, and thus I'm gonna have 4 over 2 phi plus 1, and I'm gonna write my I prime prime of phi to be equal to 4 over 2 phi plus 1 minus 2 x to the phi plus 1 over phi plus 1, the limit from 0 to 1, and if you do the same approach here, you're going to end up with minus 2 over phi plus 1. Thus, my I prime prime of phi is 4 over 2 phi plus 1 minus 2 over phi plus 1. Now, here I can integrate. I'm going to integrate whole thing with respect to phi. I'm going to say the integral of I prime prime of phi with respect to phi is equal to the integral of 4 over 2 phi plus 1, again with respect to phi, minus the integral of 2 over phi plus 1, again with respect to phi. So this term here is going to become I prime of phi, because we're reversing the integration according to the fundamental theorem of calculus, equal to this term here. Let me write this. Actually, calculate this term here. The integral of 4 over 2 phi plus 1 d phi. I'm going to let u be equal to 2 phi plus 1. My du is going to be 2 phi d phi. And here, I can split this up as 2 times 2 d phi over 2 phi plus 1, which is going to give me 2 times du over u. According to the laws of integration, 1 over u's integral is 2 ln u, which means my integral is 2 ln of 2 phi plus 1 plus some constant of integration, which I'm not going to put here, but rather when my fork is done, I'm going to put a constant plus c here. So this term here, therefore, is 2 ln 2 phi plus 1. And this term here, again, according to the laws of logarithms, is 2 ln phi plus 1. Therefore, I'm going to write this again. My I prime of phi is 2 ln of 2 phi plus 1 minus 2 ln of phi plus 1 plus c some constant of integration. And sorry, how should we find this constant of integration, which I'm going to call c1, because we're going to integrate once more to find I of phi. I'm going to equate this thing to I prime of phi, which was, if you remember, I prime of phi was the integral from 0 to 1 of 2x to the 2 phi minus 2x to the phi over ln x dx. And I'm going to equate this to this term right here. And I'm going to get 2 ln of 2 phi plus 1 minus 2 ln of phi plus 1 plus c1 equals to the integral from 0 to 1 of 2x to the 2 phi minus 2x to the phi over ln x dx. And if I just let phi be equals to 0, I'm going to get 2 ln of 1 minus 2 ln of 1 plus c1. 2 ln of 1 is 0, that's going to be 0. It's equal to the integral from 0 to 1, 2x to the 0 minus 2x to the 0, which is going to give me 0. And definite integral of 0 is 0. Thus, I get c1 equals to 0. So, my I prime of phi finally is 2 ln 2 phi plus 1 minus 2 ln of phi plus 1, and this is my I prime of phi. Now, if you want to find the I of phi, I'm going to be needing to integrate this whole thing once more all over again. So, the integral of I prime of phi d phi is equal to the integral of 2 ln 2 phi plus 1 d phi minus the integral of 2 ln of phi plus 1 d phi again. And the integral of log of the ln x is a little bit difficult to solve, but I'm not gonna make this video longer, but you can go to my channel and see that indeed the ln x dx, this integral by integration by parts, is x ln x minus x plus c, some constant of integration. Thus, if I want to find this term right here, first of all, this is going to become I of phi, which is equal to 2 now I'm going to let u be equal to 2 phi plus 1, and du is 2 d phi, and this is my 2 d phi. Thus, this term 2 ln of 2 phi plus 1 d phi is 2 ln u du. And according to the term that is stated here, I'm going to get u ln u minus u. This is the first term here. And this term here, 2 ln of 2 ln of phi plus 1 d phi is 2 times phi plus 1 ln of phi plus 1 minus phi plus 1, and this is my whole integral here. Therefore, my I of phi is going to be, recall that u is 2 phi plus 1, therefore I'm gonna get 2 phi plus 1 ln of 2 phi plus 1 minus 2 times phi plus 1 ln of phi plus 1 minus phi plus 1, and it's going to be 2 phi plus 1 ln of 2 phi plus 1 minus 2 phi plus 1 ln of phi plus 1 minus 2 phi plus 1. These two are going to go plus. These two are going to go away. Sorry, I forgot to. Should have added in here. Should have added a 2 phi plus 1, and now 2 times phi plus 1 ln of phi plus 1 plus 2 phi plus 1. These two are going to go away, and my I of phi is 2 phi plus 1 ln of 2 phi plus 1 minus 2 times phi plus 1 ln of phi plus 1, plus some constant of integration. So we're almost there. You just gotta find this constant of integration. And if you recall I of phi, it was in this form of x to the phi minus 1 over ln squared x dx. And if we equate this together and let phi be equal to 0, you're gonna find that this term here is gonna be definite integral of 0, and all these terms here are gonna go to 0. Thus I can say that c equals to 0 as well. And I of phi is equal to the integral from 0 to 1 of x to the phi minus 1 squared over ln squared x dx, which is 2 phi plus 1 ln of 2 phi plus 1 minus 2 times phi plus 1 ln of phi plus 1. And that is the final form of our integral, which was one hell of a work, but hopefully you did understand it. If not, ask me in the comments, and please like and subscribe, and I'll see you next video.